Welcome, welcome. So in this video, we are going to go back into our note packet. I'm going to skip over this uniform distribution, and we are going to talk a little bit about this exponential distribution for an exponential random variable. So um, on this first page, so I'm on page 7 now, you can see that the exponential probability density function is defined for any value that's larger than 0. And so some common situations that this exponential model might be useful are for modeling some lifetimes of things. So light bulbs, electrical components, things like that. Another common thing in the real world that an exponential model can be useful for are waiting times. So like modeling a waiting time at a checkout line for a computer search, etc. The plot of the PDF for an exponential random variable with lambda of zero point 0.2 is given here. And you could notice that there is some kind of right skewness, so with this particular distribution. Okay, so that is a little introduction to what the exponential distribution is and how it can be useful. We also have a couple of theorems here. So we have a formula for the expected value of an exponential random variable and the variance. Both of these are on your continuous distribution sheet as well. So with that info, let's dive into this problem. So we're supposing here that a new computer battery has a charge that follows this exponential distribution with lambda equal to 0.0625, and we're then prompted to find this probability that the computer lasts for at least 3 hours. And so I'm going to start by just writing out the density function for this particular value of lambda. And so you could look back on the previous page to look at the form. And that density function looks something like this. And we could either keep it like this and kind of be a little bit lazy and assume that the reader of this understands that it's 0 if y is less than or equal to 0, or we could say put in the explicit 0 otherwise statement, which I'll do here just to do it. And then we are prompted to find this probability. So the probability that y is greater than or equal to 3. That can be found just by setting up this integral from 3 to infinity and then putting in the density function that I wrote a few seconds ago. I'm already at this point quite lazy, and I do not even want to evaluate this integral, even though it's really not that bad. And so in a second, I'm going to hop over to ChatGPT to let that do that evaluation for me. Alternatively, so I'll say, or if we don't want to use ChatGPT and we want to use R instead, we could say that this is equal to 1 minus the probability that y is less than 3. Then we know that unlike for discrete distributions where the equality sign really mattered a lot, for continuous there is no probability that y is exactly equal to 3. So this is equivalent to this, again, because the exponential is a continuous distribution. And then we could plug into R 1 minus p exp 3 0.0625. So again, we're just using that p function just like we've done in the past to compute the probability that a random variable is less than or equal to, in this case, 3. If you plug that into R, you wind up with 0.829. And because I am technologically incompetent and I'm worried that if I leave this, I won't be able to get back to it, we're going to do this last part before I hop over to ChatGPT and figure out the expected usage time, which is a straightforward calculation because we have the formula that the expected value is just 1 over lambda, and we have lambda. And so this is just a straightforward calculation to get to our expected usage time of 16 hours. All right, so now that I'm not going to come back to this in this video, I will, I guess, mention that the exponential random variable also has the memoryless property. So you might remember that this is just like the geometric. That was the discrete random variable that we encountered this memoryless property with earlier in the semester. The exponential also has this property. Okay, so coming over to ChatGPT, again, I've already put this as an input, so you could see what I asked ChatGPT to integrate the function 0.0625e to the minus 0.0625y with respect to y from 3 to infinity. ChatGPT doesn't ever shut up and does all of this work and blah, 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 blah. And it gives you this answer at the bottom. So e to the minus 0.1875. And then I prompted again, no, like actually calculate that, please. And so then it goes through the calculation and you wind up with the same answer as before, 0.828. So again, you're welcome to use ChatGPT for things like this. You're also welcome to use other sources on the web that will calculate integrals.